Welcome to Practical Electronics 4, Real Life Application of Transistors Part 2, How to Build a Solar Powered 5V DC Phone Charger Using Transistors. So look at this is our circuit diagram, and this is the real stuff you are seeing here. You can see. So this is the input. Let me show you the input. This is from the solar panel. You are seeing here. What you are seeing here. This is from the solar panel. So as you can see, this 21 volt from solar panel. This from 18 to 21 volts. And then I have the charger that you see here. You can see. Let me connect it. These are the inputs. Connect it to the panel, positive terminal, and then the negative terminal. So you can see. So you can see it. What you are seeing here, these are USB. If you have a bad charger, you don't need to throw them away. Be keeping them. Look at the USB ports. You can salvage them from a condemned phone charger, and then some of these components from your scrap container, you can get some, and then once you don't have, you can buy them from the market. So you can see. So what exactly the circuit you are seeing here is exactly what you are seeing here. So with this, you can plug in the USB cable. Then you can power not just phone, any other gadgets. You can plug to charge your phone or any other device. You can see this is music player. You can see. So you can charge other devices from it, straight from our solar panel. So you see now, one of the problems we are facing in this country is power problem. Now, if you just go to the market and you just buy just the solar panel, like what some people did, you just buy the solar panel and say they want to use it to charge your phone. How are you going to charge your phone with just this? You must need a circuit, which is this, because with the voltage you are having here, this is 21 volt. What your phone needs is 5 volts. These gadgets, the input to this gadget are 5 volts. This one also, if you look at it there, the input is 5 volts. So you cannot connect this directly to your phone. You're going to destroy your phone. So we need something like this that will bring down the voltage, the 21 volts. As you can see, my input here, 12 to 24 volts, this input. Then my output is 5 volts. It is steady, it is regulated. So you need this to bring down this higher voltage down to this voltage so that you can feed it to your phone or from your solar panel. So you can see it. So before I will explain the circuit, let's take a look at this. We're going to talk about types of DC power supply. Types of DC power supply. We have the linear mode power supply. This uses regulator to provide a stable DC output, just like the one that we have here. So this is linear mode power supply. You don't have any digital stuff, any microcontroller, anything on it. You can see. So what you have here is a regulator. Itself, this circuit itself is a regulator. That means it's regulated 5 volt DC voltage. So you can see. So then the second one, we have switch mode power supply. Let me show you another one here again. Look at this. This switch mode. They do the same thing. They serve the same purpose. It's to provide input 12 volt. You have 5 volt here. The same thing with this also. Input 12 volt. I have 5 volt here. They basically do the same thing, but they have different technologies. This uses what we call PWM. So they call it switch mode SMPS. SMPS, switch mode power supply. This uses high frequency digital signals, PWM, pulse width modulation, to step down or step up or convert one DC voltage at one level to another DC voltage at another level. So that's what this does. So let me power this from my battery, this 12-volt battery. So you can see, so what you have here is 5 volt, which means I can as well plug this to charge your 5-volt devices, your phone. So you see, so this is switch mode power supply. So this is switch mode power supply you are seeing. Then we have another one, battery based power supply. So this provides a DC voltage direct from batteries. It's just like example of what I have here. What I have here is just batteries. Nothing is converting, there's no converter in, just batteries. So I can connect this straight to, you can see my bulb here is just powered directly from the batteries. I can connect this to a DC motor or anything. You understand? So then the last one we have here is programmable DC power supply. This allows the user to adjust voltage and current as needed. So let me show you another example of it. So look at this here. So this is the input, and then this is the output. So if you look at this here, you can adjust the voltage, you can also adjust the current. This is called buck boost converter. This is also switch mode. So you see, this one is fixed, the output voltage is fixed. This one also, the output voltage is fixed. So why this one, the output voltage is variable. Now this one, the output can be higher than the input, the output can be also lower than the input based on your adjustment. So you see, so let me power this so that you see it. Let me connect it to the solar panel. So you can see there's a reading there, so you can see the output. I can adjust the output voltage from here. Now this is how to turn this. You can see I'm bringing it down. I can also bring it up. So you can see it bringing the voltage up. Let me set it to 12 volts. So you can see. So this is programmable. It allows the user to adjust the output. So you see. So let's get back to our number one, which is our practical is based on number one here. Our linear mode power supply. In our next practical, we are going to treat this and this. We're going to make this. So for the sake of the beginners, we have to start with this. You need to know how to build. For you to be able to build something like this or something like this, you need to start from here. You need to start with this. They both have their advantages and their disadvantages. So for a beginner level, and you want to just quickly put up a system like this that will enable you to charge your phones from the solar panel, so that you don't depend on the grid power supply. So before I show you things here, let's go to the paper. Let's go to our book here. The circuit diagram. Now you need to understanding of circuit diagram is very, 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 very important. It is very, very important. So let's start from here. This is the input, and then this is my output. So look at this. This is a diode. We also have a diode here. You can see we also have another diode. We all have diodes here. There are different types of diode here. This one is just a normal rectifier diode. So look at them here. So look at one of the diode at the input side. Then we have another diode here at the output. So you can see it. We have another diode at the output. So this diode, even without this diode, this circuit works, but it's there for polarity, so that if you mistakenly reverse the polarity, you don't damage some stuff. So that's what this diode is doing here. Then this diode, so I'm going to explain it as I'm explaining there. So let's identify the components on the circuits. The first thing, let's identify a component. This is a PNP transistor, this is an NPN transistor, this is also an NPN transistor. So we have 3 transistors here. So look at them. The PNP transistor, the one we have here. Then we have the NPN transistor, the one we have here. Then we have another NPN transistor, which is this. Now you can see I used A1943. You can use any other version you want. I used TIB41 here. I also used TIB41 here. So if you look at it there, so when I was doing this thing, I didn't have this TIB41, but I have this thing from one of my scraps, so I just bring it out. This is also an NPN to serve, and it's also doing the work. So you see, so those are the transistors they have here. You know, take note of it. We have one PNP. This one here is the one that's driving. The voltage comes in, it gives the voltage out. So each of these one, they are doing their jobs. They have jobs that they are doing. Now let's look at other components also. We have capacitor here. We have capacitor here. We have capacitor. We have capacitor here. So let's look at the diagram here. Look at this capacitor here. This one that you're seeing here. Look at it here. And then this one that you see here. Look at it here. Then this one that you're seeing here. Look at it here. Then this capacitor you are seeing here. Where is it? Okay, we have the hand. Okay, look at it here. This one here. This one here. This one here. This one here. So you can see it's okay. So let's look at the resistors here. So let's look at this resistor here. If you look very well here, it's just in between. This is just down here. Then this one here, look at it. You can see it there. Then we also have this one here. Look at it here. Then we also have which other? Okay, we also have another diode. Resistors here. Look at it there. Then we also have other ones here. Look at them here and look at them here. So you can see them. Then we have LEDs. The indicators. Look at one indicator here. Look at the indicator here. We have 2 other indicators here. Look at them here. Look at them here. And then what next again? We have Zener diode. This is Zener diode. Look at it down here. Look at it here. You have seen it. And then what other component again? We still have the second diode here. Look at it. I will explain this why I put this diode here. What is the diode doing here? Then we have fuse. This is very important so that in case you short circuit the output, look at my fuse wire. Look at it here. So it's very important, the fuse wire, so in case there's short circuit. So you see. So now let me explain how the circuit works. So this transistor that you see here, the current rating. Now when you are designing something like this, you will need your output current that you need. Now whatever current that you need, make sure your power transistor, the current is twice what you need, or 3 times what you need, or 4 times of your required current. For example, now if you need the output 5 amps, make sure your transistor is more than 10 amps, 15 amps, 20 amps. Make sure this one is far higher than what you need. You understand? So and another thing again, make sure you put this on a heat sink, because this is going to get hot. As you put load, when you connect load there, this is going to get heated. So you can see this is aluminum. So this is screwed to aluminum heat sink that you're seeing here. Then now we have, in our previous practical with transistor, I don't need to be explaining all those again. If you don't know about transistor, go and watch my previous videos. I won't be doing that here. I've already explained to you how transistor work, the PNP and the NPN, the differences, how they work. So I'm not going to do that here. but this is not the purpose of the video. The purpose of the video is how to make this thing. How is this thing getting 5 votes here? How am I putting 12 votes in here, or 21 votes here, or even 30 votes here, and I'm still getting 5 votes here, which is what we are doing. I've already explained transistors already, for which I'm not going to do that here. So now if you look at this PNP, the input here are the emitter, then we have our outputs at the collector. What this transistor is doing is to make this transistor conduct fully. That's what this one is doing here, this arrangement. You understand? Now this guy here, what is this one doing? This one is feedback. You understand? Now this is a regulated power supply, so you need some sort of feedback. It's all like the way you have mirrors on your car. Your mirror tells you what is going on behind you so that you adjust your driving. So that's what this one is doing here. So you see, then this Zener diode, this is 5.1 volt. Now our target voltage is 5 volt. So I have 5.1 volt Zener diode here. Now my output here, I'm going to get 5.7 volts. You understand? This is real life practical. When you do this thing, you measure it with your meter, you're going to get 5.7 volt. And I need 5 volts. What do? You have to put this diode here. 0. There will going to be a voltage drop of 0.7 volts. So when you remove 0.7 from 5.7, you'll get 5 volt output here. So you see that 5 volt. Now make sure you pass it through a fuse, like the way I did it here. Look at my fuse. Very tiny, something that will easily get melt when you bring short circuit the output. Now, why is this 5.1 volt Zener diode again doing it? Very, very important. It's to protect your phone. Should in case something happens, goes wrong here. Something goes wrong and the input now become the output, you're going to lose your phone. So to protect your phone of 300,000, 150,000 naira phone, you need to protect. How much is this Zener diode? Just 15 naira. So you see. So now once there is something, the voltage goes higher than this 5.1 volts, the fuse is going to cut. So you see, because it will appear as a short circuit here. For example, now something goes wrong and the 12 volts all coming out from here, and this Zener diode will make sure it will try. This Zener diode is just acting as a bulletproof. Like for example, now a policeman putting on a bulletproof, and the bullet is coming towards his body, and the bullet will fall on the bulletproof to take the forces. So what this guy is doing here is Zener diode. So in the course of short circuit, this fuse is going to melt. Make sure the fuse is very, very tiny wire, like the size of your hair. That's the kind of wire you put here, so it will easily melt to protect your phone. That's what the Zener diode is doing there. So you can see. So there are 3 indicators, LEDs here. Power goes in. This is to show that there is power. Let me power the circuit once more again. So you can see it. You can see the 3 LEDs, these inputs. So to show that there is input here, then this LED here is to show that there is output at this point. Now this LED showing up, it means that the fuse is okay. So you see the fuse. If this fuse is removed, this LED will go off. So once you see this LED is not coming on, to tell you that something is wrong with the circuit. So you should check the circuit very well. So you see, so those are indicators. Then what we have here is my female USB connectors. So now let's see how these things produce 5 volts here. Now, if you disconnect this part, leaving only this part, and you put 12 volts here, you are going to get something close to 12 volts. You understand? Now, we want something that will monitor the output and tell this guy, hey, the voltage you are giving is too high. I want you to bring down the voltage to this particular level. So while we use this Zener diode to give us a reference voltage, 5.1 volt. Now if you put 12 volt here, 12.1 volts Zener diode, that's what you're going to get here. Whatever voltage you put here, if you put 9 volts Zener diode, that's what you're going to get here. So since we need 5 volts, so I use 5.1 volts Zener diode at this point. So what this transistor is going to do is that you can look the base now is connected to the output. The output now become the input to this transistor. So this transistor is going to try to pull the base of this transistor down to the level of this Zener diode, which is 5.1. Now 0.6 is added to it, so which is going to give you a 5.6 volt. You know, this 5.1, you are getting 5.7 volt. So you can see now that 5.7 volt is too high for our phone. So I have to put this diode here. It's going to drop. 0.6 will be dropped. So you're going to get 5.0 volt or 5.1 volt here. So you see, which is okay for our phone. So that's how the system works. So you can see now this input might be fluctuating. For example, now you can go from 24 to 15 volt. You see how steady 5 volt. From 15 to 12, you see how steady 5 volt. Make sure that such kind of cycle, make sure the input voltage is higher than the output. You don't just go and put 3 volt and expect 5 volt. It doesn't work that way. No, make sure the input. It's just like you have a water tank up and then you put tap. The tap has to be lower than the tank so that the water can come out. That's how this works. So this is very simple. You understand? That's what we call it linear. There is no digital stuff here. Everything is just purely analog. So you see, it's very, very simple, and this device works very well. I've used it to charge big, large Android phones. So you see, so what I have here, what you have here is over 3 amps, over 4 amps. What I'm having here now, depending when you are designing this, the higher the current you want here, make sure your transistor you are putting here should also have a higher current rating. So because this is one driving the load, that's why we have to put this on heatsink. When it is loaded, it's going to get hot. The temperature is going to increase. So you see, so it's very, very simple. I'm using it to charge my phones at my workshop. So you see, this is very, very simple. Unlike this one here, this is far more complicated. They are digital stuff, so you need to, as a beginner, you don't start with this. You have to start from here. This is very simple. You can easily build this. So those who are beginners to electronics, you understand. Now this, I don't recommend to use this on batteries. Just strictly solar panels. You understand, because there is going to be some heat energy being wasted on this. So I don't recommend this on battery powered. You understand? So strictly we are dealing with solar panels here. Solar panels. So you have solar panel. Now if you do your calculations very well, currently 100 watts of solar panel in Nigeria, in the area where I'm staying here, is between 30 to 35,000. Now you buy that solar panel, let's say 30,000, and this I don't think you spend up to, with this now less than 5,000, you build the whole of this. I don't think you spend up to 5,000. You build this, and then every day continue. Now, okay. Now another person now buy a gasoline generator, and each time he wants to charge his phone, you have to put, let's say, like now currently now a liter of fuel now is around 1,000 naira. So you put, like, let's say you buy like 2 liter or 3 liter, put in your generator, let's say like 2,000 naira. You including your transport, let me say like 2,500 naira on fuel. Each time you want to charge your phone, and now if you do that for like 30 days, now multiply that amount by 30. Let's say 2,500 naira fuel every day for 30 days just to charge your phone. You know what the amount you are going to see. So this is far more better. Get the solar panel. So solar panel is not something that will just expire. You will use it for many years. So you see, so getting stuff like this is advisable because of the nature of our power system. Our grid system is not stable, and there are some towns and some cities that don't even have the grid line. So you see, so now if you observe this very well, this is different from the academic knowledge we have in our schools. You do also sort of kind of equation, you solve all those equations, you do all those equations, and someone will pass exam very well, and somebody studying electronics engineering, you solve those equations, you write the exam, and you pass very get good grade. But you can't sit down and put these things in real life, practical stuff like this is very bad. It's not good. So you studying electronics engineering in school, please just try and make sure whatever you are reading, make sure you put it in real life, because that's the essence of why you are going to school, to go and study electronics. Come out and make something that will solve problems, make life easier for humanity, not just go and get paper, this, and just go away. No. So that's why we have a practical electronics. So I advise our schools, in as much as we have been doing calculations on transistors. You see all those theory calculations on transistors, but you hardly find where we put those calculations into practice to make something in real life. Now what this thing is solving a problem. It's solving a problem. Knowledge of electronics is put together and it's solving a problem. And knowledge of resistors, knowledge of capacitors, knowledge of transistors, knowledge of diodes, put them together and we are making something, creating something. The electronics is a very interesting field of knowledge, but the way it is being taught in schools so makes some of our students look uninteresting. The looks uninteresting. So you can see. So this, as I've said, as I've done mine, go and do yours. Please take a look at the circuit very well. You can learn how to draw circuit by hand. I'm also going to teach you how to draw circuit diagram using softwares like Proteus. So you should be able to get a notebook, be drawing circuit diagrams, clean circuits by hand this way. Now we're also be teaching you now subsequent videos how to simulate this. You can also simulate this on Proteus. Measure the input voltage, measure the output voltage. You can also simulate this on Proteus. So we'll be coming to the end of this practical now. So this is all the aim of this practical, how to make this. This is a Vero board. So if you are buying this, make sure it's the dotted type. The one that have dot, not the one that have stripes, lines. Make sure it is. And the aluminum, you can get this from scrap. You can even go to where they are making aluminum doors and you can buy pieces of this from them. Then some of these things from the scrap electronics, without any of them, you can as well still buy all these things from the market. Then get this from an old phone charger. So those of you that have, if your phone charger gets bad, you throw it away. Please don't be throwing them away. Keep them. There are some useful things, especially this USB port. So you don't need to go and buy this in the market. So you see, so from there you can see them. I removed from my spoiled charger. Then some of these cables you can buy them as well in the market. You can see, you can just buy this. Then use as a piece of wood to prevent this from other metallic object from shorting the output. So use a piece of wood. So you see, so you can have something like this around for charging your phones. So you see, so this works very well. It charges bigger phones that require 3 amps. It charges them very well. So you see, works very well. Just like I've said, this is we are just concentrating on solar panel here. I don't recommend using this on batteries, just for solar panels. So you see, now in next I'm going to be teaching you. I'm also going to construct the switch mode, something like this. You can see something like this switch mode, or even something like this. I will be building this also. I'll be building this. Now sometimes it's not just about having money and be buying these things. As an electronics, someone learning electronics, even if you have the money to buy these things, learn how to build this yourself. so that if this thing is not available for you to get, what do? You get stranded. So you need to know how to build this yourself. I'll build one. I've used it in somebody's project. So next practical, I'm going to build this where we can even adjust it. You understand? So it's good to know how to build all this stuff. So if this thing is not available in the market, just like if you see this, I bought this thing, I added these Zener diodes. This didn't come with protection, so it's very important. So I had to put 5.1 volts and the 5 volt each of the output. Now there are 4 circuits here, just like 4-in-1, 4 different channels each controlling their own output here, not just one. So if you are buying stuff like, make sure you put 5.1 volts Zener diode, 1 watt Zener diode, so that in case something goes bad, your phone will be protected. So forthcoming video, I'm going to teach you guys on switch mode power supply. So this is us. We're going to stop here. So go and now the first thing I want you to do, go to your Pro Tools software. Simulate this. We'll do that in our next video. I'm going to do that. I'm going to teach you how to simulate this on Pro Tools software. We'll measure the input and then we'll now compare it with the real life working one. We'll bring our meter, measure the input, and then in the Pro Tools software, you see the difference is just going to be very, very minor, very simple. So you know how to simulate this thing, and then in real life, make this. So I'm giving this as an assignment to you. Go and do it. Go and try and do this. So this is the end of today's practical. So please, if you like this video, please share it, like it, subscribe to my YouTube channel. Thank you. Goodbye.